what we are investigating. What I'm investigating is subsoil. Subsoil, not surface soil. You see, soil below the ground surface. Soil below the ground surface. We want to know its properties. We want to know its properties. So the knowledge of what I say, the knowledge of gaining properties of subsoil. The knowledge, what I say, subsoil investigation means getting what is the properties of subsoil by conducting field and laboratory tests. By conducting field and laboratory tests for the benefit of selection of foundation, selection of proper foundation system. ఇటువైపు సాయిల్ మెకానిక్స్ ఉంది, అటువైపు ఫౌండేషన్ ఇంజనీరింగ్. ఆ రెండింటికి మధ్య ఒక బ్రిడ్జ్ వేస్తే రెండు కలిసిపోతాయి. So we want to connect soil mechanics and foundation. We have two subjects in geotechnical engineering. First is soil mechanics, the second one is foundation engineering. So now we are entering into foundation engineering. The first topic is subsoil investigation. Subsoil investigation means getting information of the subsoil properties by conducting field and laboratory tests for the benefit of selection of proper foundation system. For the benefit of selection of proper foundation system. This is the meaning of subsoil investigation. So many times in subsoil investigation, we conduct field tests as well as whatever see in subsoil investigation. The very important discussion is collection of soil sample. Collection of soil sample from field. Then whatever collected soil sample, you will test in laboratory. We will test in laboratory. From that we can assess CN5, what we say CN5. So once you know CN5, I can able to calculate bearing capacity, CNC, QNQ, 0.5 gamma, PN gamma. So this is the fundamental bearing capacity equation proposed by Tarjagi. So from this we can able to calculate ultimate bearing capacity. So without knowing C, here you can see NC, NQ, and gamma. They are not visible, but their presence is there with 5 value. So if you know 5 value, you can able to get NC, NQ, and gamma. So CN5 actually they obtained from laboratory testing and testing on sample. Sample is collected from field. So this is 360 degrees now. Your learning is now not 90 degrees or 180 degrees. It is 360 degrees. See why I am collecting soil sample? Can anyone tell me now? Why I am collecting soil sample? Why I am testing soil sample? What is my main objective? Can anyone tell me now? And anyone is ready to comment on this? So collection of soil samples is nothing but is a part of soil investigation. So we use it to collect soil sample from the field. And also during collection, we use it simultaneously. We use it to conduct some field tests, like very popular field test in India, standard penetration test, SPT, and CPT. CPT is a sophisticated test, cone penetration test. So we use it to discuss different field tests. Laboratory tests are covered in soil mechanics. So we highlight field tests in foundation engineering. As you know, field tests are more reliable than laboratory tests. See, we have a choice. Now you see, you are an engineer. You are supposed to conduct field tests and laboratory tests. The first preference should be field test. The reason field tests are more reliable, you can rely much on field tests because of what I say, more precision and what I say, less disturbance. Because you are conducting whatever you see, you are putting load or you are putting what I say, energy directly on ground. So you can, without any disturbance, I think. So during sampling, there may be disturbance. So that's why you see field tests are more reliable than laboratory tests. But if you are limitations of project cost, so generally you see, if you think that your project is having less significance, we prefer laboratory test. We'll collect soil sample, we'll bring the sample to the laboratory, and then we will test the sample. From that we will arrive C5 gamma. Ultimately, we will calculate ultimate bearing capacity. From that, we can able to calculate safe bearing capacity. While you are designing foundation, the first step, anyone can tell me? Area of the footing is equal to column load by SBC. This is the first step in the design of RCC footing. So if you want to know SBC, we should have this knowledge. Collection of soil sample, nothing but subsoil investigation. And after collecting soil sample, bring the sample to the laboratory and test the sample, get the properties and put these properties in ultimate bearing capacity equation. From that we can get SBC. So why we are reading soil mechanics? Why you are reading foundation engineering? So soil mechanics and foundation engineering combinedly called geotechnical engineering. Start with soil mechanics, end with foundation design. So you hope you understood the entire design process